here?
Yes.
Is that okay? All right. So Nadia has organized the cost of attending her top two school choices in the table above. Her wealthy uncle has set aside $22,000 per year, $20,100 per year to use for both tuition and room and board if she attends school A for 3 years and school B for 1 year. So they're attending them for different amounts of time. How much additional money will she need to attend both schools and take into account scholarship money? So it's a pretty straightforward question. It costs her, and you could add these up here. We'll maybe put at the top. It costs her $36,700 to go to school A. It costs $12,500 to go to school B.
Mhm.
And she's going to school A for 3 years and school B for 1 year. But the tuition is reduced, at least in the case of school A, by this amount per year, because her wealthy uncle's giving her some money. So that's you would deduct that out. So you've got 36,700 less 22,100. Again, this is kind of a calculation you'd like to be able to do. The numbers actually line up pretty nicely to be able to do that. So this is 14,600
Don't
per
you have to
year.
multiply the 36,700 by 3?
You could. I mean, this is not a calculator problem, so we talked about it maybe being, but the smaller numbers you can get with to work with are generally preferred. So like rather than waiting till the end to simplify, it's better to do it early on. But you could absolutely multiply that by 3, but then you're multiplying the scholarship by 3 as well because you get that per year. So this for 3 years, whatever that is, and then it's the 12,500 for 1 year, and that'll tell us how much she needs um, for tuition. Um, oh, sorry. The tuition is good for even the last year. I guess I didn't see that. So per year for both tuition and board. Okay, so she's got, because if you add these up, like the first number here is 43,800. That answer is obviously not there. But if you take into account the fact that she's getting scholarship money for yet another year, you can add up this 12,500 and then deduct out the 22,100 for that.
Okay.
So probably the best way to do this problem is to figure out the total cost and then subtract out the scholarship that you're going to receive for this.
So the answer would be the 43,000 plus 12. That would be the answer. But you wrote on the line.
Yes. Well, it's whatever that becomes. I mean, I can look
Yeah.
for it. I mean, it's but I look now that I see that now that I see us working through the problem, that the better option would have been to calculate the total cost for 3 years plus the 1 year, and then deduct out 22,100 for 4 years.
Well, isn't that what I said, that you multiply
Yeah.
the 36? Okay.
Yes.
Okay.
And so we got 37,300 plus 12,500 minus 22,100 times 36,700. All right, are you able to get that number?
Yes.
Okay. All right. So let me post another question here with just changing the numbers and treat it as a timed exercise. So you really want to try to knock it out in 60 seconds if you can.
Wait, let me get my calculator.
Okay.
This one you probably would be given a calculator, right? Because it's pretty big numbers.
Yeah, I'm revising this question based on our work because it is too large. It's perfect for a calculator, and in fact, if I make the numbers more difficult, it's really perfect for the calculator. All right.
Okay, so once you get the value of 2 years, like for school A and school B, do you add those together and then subtract the scholarship?
Yeah, I mean, there's a little bit of background in this problem. I mean, most students attend school for 4 years, okay,
Mhm.
and some do two and then two, like a community college and then a non-community college, and some students might even take 3 years because they get through their undergraduate and they go 1 year in a graduate school or something. So your cost is however many years you're in school A and how many years you're in school B added together. So it's 23,900 times 2 for school A
Yeah.
plus what do we got there? 15,100 for school B for 2 years, and
Okay.
then go ahead.
So then oh,
Then you subtract out the scholarship for
times 4. That's the
yeah
part. Okay. Because I was getting a very big number and I was like, that can't.
yeah
Okay, so then you do minus 67 to 100. So it'd be 10,800 C.
you got C for the answer.
Yeah.
Okay, let me check that. It's got to have the next question queued up. Yeah, C is the correct answer for that. Okay. So got a new question here ready to go. We're switching into what appears to be a physics question, but it really isn't. It just has that appearance because it gives you everything you need to answer it. You've probably seen this form of the question in another class, but we'll work through it. Okay. All right. So in general, this is one of those really long, wordy questions. In general, an object moving through the air can be treated as a point mass instead of an extended object. So I'll point this out to you like none of that's useful thus far. So when we reread it, we don't have to look at it again. Physics student knows that the mass of a large exoplanet is 160 times the mass of Earth. She wants to simulate throwing an object directly upward in the air with an on the exoplanet with initial velocity v0 of 56 feet per second from an initial height s0 of 60 feet with a gravitational acceleration a of 6 feet per second squared. So that information is all useful because if you looked up here, you would see, okay, I got an equation. When they give you an equation, usually they give you the values for it, or you have to use the equation in some capacity. So everything else has not been useful, but we can write this equation as minus 1/2. A is given as 8. T is your variable, plus 56t plus 60. Okay, so this reduces to minus 4t squared plus 56t plus 60. So it's really good if you can combine those all together. After how many seconds will the object reach the ground? So notice this 160 times really didn't even come into play. It was just extra information.
Okay.
Basically everything up until right here is irrelevant. And this is the style that you might see pretty often, where there's, we talked about it before. So if you've taken physics, and even if you haven't, they cover this in your classes. This is a parabola. It has some sort of a shape where it starts at 60, goes up, and it hits the ground there.
Okay.
So this is the x-axis, and this is when the output, the y value, equals 0. So essentially, I'm asking you to solve this quadratic for 0. So do you recall some ways to solve a quadratic?
You can complete the square, isn't that one?
Okay, I'm gonna go down here and put complete the square. How about factoring?
Yes.
Factoring is a good option to always try. Graphing, if this were a calculator problem, might be good. You can also use the quadratic formula.
Yeah. Okay.
So this is something that I've noticed and that I think will be helpful for you. A lot of the problems that I've seen, you can definitely factor, but they may not appear like you can factor them in the first step there. So I think we covered this in great length at some point. The GCF is the first thing you want to factor if you can, and it happens to go into all these numbers, which is not that uncommon. Like it's pretty common for that to be the case. So, and if it isn't, it still works out okay. Do you remember how to factor this, and can you factor this for me?
Yeah, so the t negative um,
So two numbers that multiply to negative 15 but add up to negative 14.
negative 15 and 1.
So we're setting this equal to 0. The solution isn't to factor. There's two solutions, t minus 15 equals 0 and t plus 1 equals 0. So t equals 15 or t equals negative 1. Now, I don't include that negative 1 in my answers, but that is the where it comes backwards here. It's a solution, but it's not reasonable in the context of the problem.
Okay.
So that's why it's not included. But this is the correct answer here. So a lot of these questions are synthesis questions, meaning that if I just said, hey, here's an equation, set it equal to 0 and factor it, you could probably do that. But the words around it, the fact that they give you an equation that looks kind of scary because there's a lot of letters and not a lot of numbers, that all plays in here. So any concerns about being able to do something like this now that you've seen the individual steps?
No, I think
okay.
Straightforward.
So we obviously want to do one like this. Do you remember how to use the quadratic formula?
Yeah, I remember how to use it, but I don't remember it exactly.
Okay. This problem doesn't require it, but you would know that it needs the quadratic formula if the answers had some square roots in them. That would be a good indicator. But when they're nice answers, that's why it's always good to look at the answer space. That tells you, okay, maybe I can just factor this thing and get my answer. So the shortcut to doing this question, which I'd like you to do when you're you're working this out for me here next is just put the numbers into the equation. You're going to factor and set it equal to 0. And you should find one of your answers in there. Alternatively, you could try putting the t-values into the equation, but you wouldn't know which ones to try. So you could potentially have to try them all.
Okay.
So I don't recommend that, but give yourself 60 seconds and see what you come up with here.
Okay. T equals 3 seconds.
So you got t equals 3.
Yeah.
Sorry, I didn't hear you if that's what you said.
Yes. T.
Okay, great. Let me check that here in the solutions. Yep, t equals 3 seconds. Okay. All right. Okay, so we'll move on to question 10. And question 10 is a table question. I think you've now seen all of the variations on the questions that you might see in the math portion specifically. There are questions that just give you they're story problems. They just give you words. There are sort of like solve questions where they just give you something to do, like an action to take. And then you see some with an equation at the top. You see some with a like a graph at the top, and then you will see some with a table at the top.
Okay.
All right, so this this question starts out by saying, the table above gives data measured from the release of the latest design of the innovative space rocket version Y. The distance traveled is calculated based on the given equation. So this equation right here, we have to review sigma notation, if you haven't seen that in a while. And the distance equation is calculated based on the given equation where n is the number of time intervals and delta x is the width between any two successive time intervals. So this is the time right here, and these are the intervals. And then there's your velocity that's given. If the distance traveled by the rocket is 26,800 meters in the first 65 seconds, so you can see that number corresponds up here. What is the velocity measured at interval 3? Okay, so it might, at first glance, maybe this seems impossible. I'm not really sure. What do you think when you see this initially?
I've seen that. What's it called? Sigma?
Sigma, yeah.
I've seen that before, but the rest of it is little.
Okay, so let me review sigma notation. So let's say it's I equals 1 to 5, and it's just x. I'm sorry, it's just the letter I.
And the triangles change, right? Like change in x.
Yes. Yes. Okay, so in this sigma over here, here's what this says. It says let I equal 1. Okay, and that means that you're taking this like the I here. Let me make this squared. So you let I equal 1, so it's 1 squared. Then you let I equal 2, because this goes up, this 1 goes up to 2, and you get 2 squared. And you let I equal 3, and you get 3 squared. Okay, and then so on. But you have to sum these up each time. So it becomes 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared.
Well, yeah, it only goes up to 5, right?
It only goes up to 5. It stops at 5. This one is slightly different. This one says sigma I equals 1, n minus 1, v xi delta x. So we can do a couple of things here before we start if we just read the question again. It says delta x is the width between any two successive time intervals. So let's look at the time intervals here. 5 to 25, how many, what's the difference between those two? 20. What's the difference between 25 and 45? That's 20. The 3 to 4 here is also 20. So in your problem, delta x is equal to, and let me grab some numbers in case you want to look back at this. It's like 65 minus 45, which equals 20. So this delta x is always 20. So we can make some simplifications here. Sigma I equals 1 to n minus 1 v of xi times 20. And one of the properties you might learn if you take in pre-calculus, which you don't really need to do this question, but you can bring that 20 out. So it's 20 sigma I equals 1 to n minus 1 v of xi. Now it tells you that it's the first 65 seconds. So what is n in this problem? N is equal to 4 because there's 1, 2, 3, 4 time intervals.
Okay.
So it doesn't say that, but you can infer that from this question. So again, we're just kind of reducing this 20 sigma I equals 1. Instead of saying if n equals 4, 4 minus 1 is 3, v of xi. So let's go through this. Let's let I equals 1. So this means v of x1. Then we let I equal 2. So that's v of x2. Then we let I equal 3. We're all the way up to the end there. V of x3. And then we add these together. Well, let's go figure out what v of x1 is. V of x1, if you come back to the table, this right here, that's x1. V of x1 is that number there. So this is saying it's the velocity at that particular time interval.
There's a lot going on in this question.
There is, but at its core, it's actually relatively straightforward because it's a multiplication and add problem. X2 means at the second time interval. Well, V of X2 is 425.
Okay. Isn't it also kind of called the summation symbol?
Yes. And then V of X3, well, that's V. We don't know that.
So UV times 45 or something?
Just V. Because we're taking the actual out. But keep in mind, we're multiplying by 20 each time. So I'll put that on the outside. Okay. And the total distance traveled by the rocket, which is what this equation gives us. This equation is d of x equals sigma, all that stuff, is 26,800. So this whole thing equals 26,800.
Okay.
So again, this kind of looks difficult because of the numbers, and you might say, well, I should use a calculator. You can, but division by 20 isn't that hard, and then you're just subtracting. So division by 20, when you divide both sides by 20 here first, is, whoa, let's get there. So we get rid of one of those, and then we cut this in half, so it's 1,340. We can add these together. 80 plus 25 is 505, plus 300 is 805. So we have 805 plus V. So our V is equal to, we're going to subtract 805 from both sides. So we get something like 535 for our velocity.
And is that what it's asking for, velocity?
Yes, it's asking you to find the value of V, which is up here. So I mean, there's so much going on in this question. We could really look at it from any angle. I mean, the shortcut here is you multiply the width of the time interval to be able to figure out what the outside number is. And then you grab the numbers that you need, add them together to equal this number here. The thing is that, just seeing this question by itself won't help you, but understanding all the things that go into it, which is you have to be able to do sigma notation. You have to be able to extract data values from a table. You have to be okay with an equation like in the last problem. So I know there's a lot here. Let's work through the next one together and see if it makes a little bit more sense here, seeing it a second time.
Wait, what happened with the 710 at the interval 4?
We don't use that because n goes up, n is 4, and our equation only goes to 4 minus 1, 3.
Oh, 3. Okay.
Yeah, so it's another example of extra information and things that aren't really all that useful, but okay. So it's the same question. The table above gives the data measured from the release of the innovative space rocket version 0. They gave you the total distance traveled, 36,375 feet in the first 95 seconds. They want to know what's the velocity measured at interval 3. So what I'm seeing here is again, like, we have to be comfortable evaluating this. The 95 seconds here tells you that n is equal to 4. So your distance function is equal to sigma I equals 1, 4 minus 1, v of ti times delta t.
Mm-hmm.
So delta t, that's the next thing we can look at. It's the width between any two successive time intervals. Here's an interval, here's an interval, here's an interval. The intervals go from like 1 to 2, 2 to 3, and 3 to 4. 20 to 45 is the same as 45 to 70 is the same as 70 to 95. You can choose any two numbers you want, but you're going to always get 25. So we can substitute that in here. So it's sigma I equals 1 to 3 v of ti times 25. And I mentioned before, that number, you can always bring constants. Constants can come out of the summation. So it's 25 sigma I equals 1 to 3 v of ti. So when you're substituting I in, it creates a sum. So it's v of t1 plus v of t2 plus v of t3. And we stop there because that's when we're at our endpoint.
Okay.
And so these values, they all come from the table. Okay. V of T1 is the first time interval, but we want the velocity, not the time. So the velocity there is 325. At time interval 2, we want the velocity there, which is 450. And then the last one is V, which equals 25. And we know that all of this equals 36,375. So this one's a little bit harder because you're dividing by 25. It can still be done by hand, but I totally understand if you want to use a calculator. That's not the whole point of this question. Is whether you use it or don't. When you divide by 25 here, one thing you can do is you have to know that and these are just helpful things. 4 25s make 100. These are mental math things. So 40 of them, 40 25s make 1,000. So 400 make 10,000. Is that kind of reasonable so far?
Yeah, I think I
okay.
got it.
Yeah,
we've got. But I mean,
well, I'm trying to show you. So out of the 10,000s, you've got, because we're going to use these numbers here. 36,000. This is the mental math that they want you to be able to do. It's 30,000. Used to do this plus 6,000 plus 300 plus 75. So the 30,000. I'll just show you this real quick. I know the calculator can do this very fast, but it's 3 of those. So that's 1,200. 6,000 is 6 of the 1,000, so that's 240. The 300 is 3 of the 12 of the 4, so that's 12 plus the 3 there. And then you're going to subtract out these other numbers to get the right answer. You're going to subtract out 325 and subtract out 450, and that's how you can do this by hand, and really not a super long amount of time. What is the final answer here, though?
For B?
Yes.
680.
680. All right. Would you like to do one of these on your own?
Yeah, I think
Okay. We've got one more to pull from here. So you've seen the steps to do it. This is all this now. When we're doing it this way, it's about trying to do it in a certain amount of time. So you need to take a deep breath, and then just once I paste this into the workspace, give yourself a full minute to see if you can work through it. And you're welcome to use your calculator if you need to.
I'll try to talk, but we'll see. Okay. Okay, I got 260.
All right. Well, the answer is there, so that's good. That's a good place to start. Let me go to the solutions and see if I can find the answer here. Yep, that's correct. All right. So I've got some more questions that we can work through a new test. Do you unless you have some specific skills you want to work on for me to find some other things for us to do?
No, I think I'm gonna start doing like some actual like SAT like college ones. So once I start doing that, I'll have more like specific stuff to go over.
Okay. The the questions here are very comparable to the books that they sell. Just keep in mind that these are slightly more difficult, but that's the point, is to give you something harder to look at
I have one
than
of
what
the Kristen review books, so I'll
yeah.
look.
All right. The next thing that next Next set of questions I've got here, they're not in the 2-column format. I didn't generate a new one for today, but they're still in the multiple choice format and some non-multiple choice. So actually, let's treat this one. Let's do this one without multiple choice, just to see where you're at on this. So this is the first time we're looking at a question without the numbers, and this one actually wouldn't, the answer would not fit in the space, but I just want us to do it without it because it does kind of bias you when you're working on these, deciding if you've got it. So the cost of starting a peach crop in Alabama includes a fixed cost of $3,500 and an operational cost of $2,000 per year. So if you take some business classes, you'll find that that cost has two components to it. It's got the fixed plus the variable, and then there's a literal variable here, but that's like an X or a T type of thing. The cost, so in this case, if you're looking at your peach cost here from the first equation, you can see that it has a fixed cost of $3,500 plus a variable cost of $2,000 per year. So time, usually for time we use T. The word operational is a synonym for variable or changing cost per year. The cost of starting a peanut crop in Mississippi includes a startup cost. So that's another word for fixed cost that you might see. Peanut is $1,000 to start up and a variable cost of $500 per year. So Olivia has always wanted to try her hand at farming and just received an inheritance of $29,500 from her cousin Taylor. How much money will Olivia need in addition to her inheritance to operate both a peach farm in Alabama and a peanut farm in Mississippi for the next 15 years? So what variable does 15 correspond to?
T.
T. Very good. So this amount right here, though, this is not the peach or the peanut. You have to infer something from this question, which you have to realize that she wants to do both. Because she says that. She says, I want to do both. I don't just want to do one. I mean, she could do one. That's another way to ask this question, but she wants to do both. So there's a total cost to being able to do the farms here. So we got 4,500 plus 2,500 T. And you can see from the question that she's gonna want to do this for 29. She has $29,500 to spend it, but there's a huge but here. This doesn't just ask you to figure out how much time it is. It says she wants to do it for 15 years, but it says how much money. That's why you always have to go back to what it's asking for. How much money will she need in addition to her inheritance? So she's getting some money, but she's going to need a little bit more money to be able to operate these things. So we need to figure out, well, how much does it cost to run the farm for 15 years? So that will tell us that this right here will give you the total cost. And then we're going to subtract out the inheritance. And that will equal how much she needs to figure out how much she'll need for an addition to operate the farms. So again, you could use a calculator here. The numbers are somewhat reasonable. I'll point out that this question focuses on writing the equations, which is a very common thing to do in these tests. Sometimes they give you the equations, sometimes they want you to write them. And it's really not a complicated, it's a linear equation. It's no big deal to write. But you're going to definitely want to do that. So 2,500 times 15 plus 4,500. Do you have that value for me?
Oh,
Get it here. I'm going to get it here. So that's $42,000. And then you're going to subtract out the inheritance. And that equals $10,500. I'm sorry, no, $12,500. is needed in addition to that. So if you didn't have the multiple choice there, you would have no idea whether you're right or wrong because you can't compare it to it. So it's really a great question to try to see, where you're at on this. This is interesting. This isn't in the right order. So let me, sorry, I apologize because I don't have a quick one just like this, but I'll get one here shortly because I like you to be able to work through one here on your own.
Can I just see the last step?
Yes. Yes.
Okay.
All right, I'm getting it pulled up here and we'll be able to work through a few of these. Okay. All right, so this time I will close. Yeah, I'll not throw up the multiple choice here. This is again a really good test to see where you're at. Can you do a problem like this in 60 seconds? The time's super important here. So just changes in the words, but it's the same type of calculations. Give yourself about 60 seconds and we'll see where you're at on that.
Okay. So the per year is like the one that has the T, right?
Yes. All right, so we got 2,500 plus 2,000 T, and then the other one is 500 plus 5,500 T.
Yeah.
Okay, so we add these together. It's a $3,000 plus 7,500 T, and we're doing that for 11 years. So 3,000 plus 7,500 times 11. So that'll give you the amount for 11 years, and then you're going to subtract out the inheritance of 55,500. So it's 85,500 for this amount of time, subtract out the 55,500, and that gives you $30,000.
Wait, how did I got 27,000.
For which, for the,
Oh, for some reason I got, okay, I think I might have multiplied it now. Oh no, I got, so you do 7,500, right, times 11?
uh-huh.
That's 82,500.
You have to add the 3,000 though to it.
Oh.
Yeah, that's the fixed cost. And
Let's see. So then that's 85. Gotcha. Got everything but that.
that's okay. It's good to keep seeing this. So all right, we're kind of here at the end of the lesson here. If you would like, I can send you over a new practice test tomorrow. It'll have some multiple choice and some non-multiple choice. Would you like me to do that?
Yeah, that'd be good.
Okay. I'll send you these notes and the screen recording here shortly. I think there's still a test 3 that you could do on your own from the one I sent on the.
Right?
Say that again.
From last time, right?
Yeah, but if you want to wait, I'll get you a new one tomorrow. It'll be around midday.
Yeah.
All right. Well, thank you very much, and look forward to helping you next time.
Thank you.
You're welcome. Have a good day.